one of the best parts of being a software developer is constantly learning new things. And for me, nothing has been more fun than learning a new programming language. However, over the past couple of months, I realized I've been spending much less time than I'd like, learning and getting better at software. Luckily for me, Ginger Bill just announced the roadmap for the first major release of Odin. So in this Monday morning review, we'll go old school, slow things down, and take a closer look at one of the most interesting emerging programming languages. For a bit of context, Odin was started in 2016 by Bill Hall, who was working as a physicist in the UK, and the origin story is the usual one. Once a man uses C++ long enough, something inside him breaks, and he spends a decade trying to build a better replacement. Odin grew out of the handmade community, where the core belief is that modern software became slow, bloated, and abstracted away from the machine. So the way back to better software is to understand what the computer is actually doing. As a result, Odin's tagline is the C alternative for the joy of programming and aims to be a language that gets out of your way, respects the machine, and keeps the mental model simple. It's also worth mentioning that, for now, there is no giant company or foundation behind the language. Bill's Patreon brings in roughly a few $100s a month, which is less than many developers spend on AI subscriptions these days. As we all know, the state of open source is perfectly healthy, sustainable, and definitely not held together by three tired people maintaining half the internet between their day jobs. Despite the lack of funding, Odin has a production compiler, a batteries-included core library, and real commercial usage. Jenga FX, for instance, relies on Odin in its professional VFX software used in film and game production, so, while small and opinionated, Odin powers serious software. At first glance, Odin looks like Go had a child with Jai, but Bill has said the language is basically Pascal in disguise. And, honestly, this is the main reason I am trying to pick up this language. Pascal was the first programming language I learned back in high school, and the fact that Bill had a Pascal book carefully placed in his video announcement background is all I needed to become an instant Odin fanboy. But jokes aside, Odin offers a familiar syntax with an old-school foundation. You get strong typing, procedures, explicit control, and very little tolerance for cleverness. This also means Odin comes with strong opinions. For instance, there is an official article called Exceptions and Why Odin Will Never Have Them. There is another opinion piece arguing that package managers are evil. This might sound extreme at first, but then you remember that NPM exists. So learning Odin is partly learning the language and partly reading why Bill thinks various features you would expect from a language are actually design mistakes. And trust me, this is an amazing learning experience, even though you might not agree with some of the design decisions. For instance, Odin avoids many features which are common in other languages. You have no classes, no inheritance, no exceptions, no generics, no implicit conversions, no function overloading, and no macros. So its biggest selling point is not that it's faster than C or safer than Rust. Odin was designed for game engines, graphics programming, simulation, and performance-critical software with the aim to remain much easier to write than traditional systems languages. The first big idea behind the language is data-oriented design. Instead of encouraging you to build deep object hierarchies, Odin nudges you toward organizing code around how data is actually laid out in memory. That might sound like a small distinction, but for use cases and workloads where performance really matters, memory layout is often more important than clever algorithms. Modern CPUs are incredibly fast, but they are still painfully slow at waiting for memory, so keeping related data together can make a surprisingly large difference. In a traditional object-oriented style, you might start by modeling the world as a collection of objects. You have an entity, then maybe a player inherits from entity, then an enemy inherits from entity, then a flying enemy inherits from enemy. In Odin, on the other hand, you are encouraged to think more directly about the shape of the data. So, a game entity is just a struct describing how the data sits in memory. Then you can define a procedure that takes an entity as an argument, store a lot of entities together, and update them in a straightforward loop. The second major selling point is explicit memory management. Odin does not have a garbage collector, but it also doesn't force you to manually manage every allocation like C. Instead, allocation is treated as a first-class concept. Many APIs accept an allocator, making it obvious where memory comes from and where it goes. Switching from heap allocations to an arena allocator for a performance-critical subsystem often requires changing just a single parameter instead of rewriting half your code. For example, imagine we want to store our game entities in a dynamic array. In the simplest version, we can allocate that array using Odin's normal allocator. But now, imagine this array is only needed temporarily because maybe it stores visible entities for the current frame. In that case, we can use the temporary allocator, and at the end of the frame, we can clear all temporary allocations together. This is the key idea behind Odin's memory management system. Instead of allocating and freeing hundreds or thousands of tiny objects individually, you can group allocations by lifetime. Everything needed for this frame goes into temporary memory, and at the end of the frame, the whole thing gets cleared in one operation. It's also worth mentioning that Odin has full interoperability with C. So rather than trying to replace the enormous ecosystem of existing native libraries, Odin embraces it. By using a foreign import, we can tell Odin which external libraries we want to link against, and the foreign block tells the language which functions exist in that library. Note that the 3 dashes at the end tells Odin that the procedure exists, but the body is not written in this language. Then you can call it from Odin like any other normal procedure. Another great Odin feature is its standard library. Despite being maintained by a relatively small team, it already includes networking, cryptography, compression, mathematics, JSON handling, operating system APIs, file system utilities, image processing, and much more. And this pairs well with the built-in support for modern data structures. Unlike C, where almost everything starts with pointers and arrays, Odin includes slices, dynamic arrays, maps, strings, enums, unions, bitsets, matrices, quaternions, and SIMD vectors as core language features. All these are usually working as you would expect, and it doesn't really make sense to go into the details here, but please let me know in the comments if you are interested in an Odin deep dive. One feature I find really interesting is the context system. Many programs need to pass around the things like allocators, loggers, temporary memory pools, user data, or platform-specific state. In most languages, those either become long parameter lists, global variables, dependency injection containers, or some other architectural pattern you studied back in college. Odin takes a different approach. Every normal Odin procedure has access to an implicit variable called context. So when you call a procedure, Odin also passes the current context along with it. This means a lower level function can still use the current allocator or logger without every function in the call chain needing to manually accept those parameters. But perhaps the most important feature is not language related. Odin is deliberately small, and it tries very hard to remove features that make code clever instead of understandable. There are no exceptions hiding control flow, no inheritance hierarchies stretching across 20 files, no implicit conversions silently changing values, and very little language magic in general. Most of the code says exactly what it does. And that brings us back to the philosophy behind the project. Odin is not trying to be the safest language, the fastest language, or the language with the longest feature list. It is trying to be a practical language that lets experienced programmers write high-performance software while staying close to the machine and keeping the mental model simple. And in today's world, we definitely need less clever ideas and more simple solutions that just get the job done. Before wrapping things up, your awesome recommendation of the day is Vikings, since Odin is obviously not just a programming language, but also the god of wisdom and war in Norse mythology. If you liked this video, you should consider joining our community, where I'm posting more dedicated weekly content. Please don't forget to smash all the buttons, and see you in the next one.